Hi, welcome to Generative AI series Storytelling. In this video, we will look at how to query a web page and article. So in this case, we will look at how to query a report on electric vehicles using LLM. So you can actually query web pages or articles and extract relevant information using LLMs, vector stores, and LangChain framework. So let's dive in. I have taken a simple article which was published by IEA, International Energy Agency. The article is about demand for electric cars. It's a very small article, but it talks about the demand, how many cars were sold worldwide in 2022, what's expected sales the current year. It also talks about the majority markets for the electric vehicles, and talks about different policies which are driving the demand for the electric vehicles across different countries, economies, and also talks about the emerging markets like India and Indonesia and different variations of electric vehicles which are coming up. Though this is a very small article, but we could have taken a very long article and queried that. But for simplicity, I have kept it a very simple article, and just to demonstrate how we can query and extract relevant information from it to create a story out of it. So let's dive in. First, we need to read the article. So demand for electric vehicles. First, we can access the page content. We would extract the page content. So I've taken the URL for the page here and use the frameworks like a beautiful soup, which is a wonderful framework to scrape the content out of the web page, which then can be passed on to LLM along with our question, and then we can extract information out of it. So I've taken this framework called Beautiful Soup and taken the specific part of the page, not all the content, only the article content, which is starting from this string and to this particular substring. And you can see this basically takes the article. I have printed here only the first 500 characters here, and it takes the content of the article. And then I'm storing the article into a particular text file. Now, this is an interesting idea. Like LLMs are primarily trained on the corpuses, which may not have all the information, especially the current information or external knowledge base. So if you want to extract information from an external source like this web page or article, what you can do is, one is we can take the whole content and pass as a context to the LLM and ask question, and saying that if you find an answer or information about the question or the query in the article, you reply with that specific information only. So you can do a question answering on the whole content. But sometimes this content are very large, like several pages or probably thousands of words, several hundred thousands of words. Then one of the option to the query, the document, is only extract the relevant portion of the document. You can think like this is the whole document now, which contains the article and probably has several thousand words. And LLMs are typically have limitations on how many tokens we can pass in a single prompt. Though, of course, the context lengths are increasing day by day. In spite of that, one is, of course, the context length limitation. And second one is the cost. If you want to pass the whole article, even though you're asking a specific question, and the information or answer to that specific question might contain in a very small portion of the document. So if you pass the whole document as a context, one limitation is the context length, the other one could be the cost itself. Then how do we extract the relevant portion of the document which contains the information relevant to the question that we are asking? So one option is to chunk the whole document, split the whole document in multiple chunks. And then each chunk, we can actually pass through an LLM. So this could be an OpenAI or any other LLM. And then create embedding vectors, which represents the semantics of that particular chunks, of those chunks. And then store those chunks in a vector store. So these are emerging solutions nowadays. The new age databases or stores called vector stores, which are primarily designed to store embeddings. And if we pass another question, embedding for another question, it can quickly search which embeddings are the nearest and returns those embeddings. And once the document has been chunked, we create those embeddings and store in a vector store. That's a part of the first two steps. Then if we ask a question, let's say we ask a question whose information is probably there somewhere in the document. And then that question itself gets converted into the embedding vector using the same LLM that we have used here to create embeddings for the document chunks. And this query embedding is now sent to the vector store. Now, vector store now searches for the chunks whose embeddings are the nearest to this particular query and returns those chunks here, maybe one or two different chunks. And then what we can do is take this question that the user has asked and those portions of the document and combine them to create a prompt. So we can pass these chunks of the document as a context and this question and combine them as a prompt, then ask an OpenAI or any other LLM to answer the question. Then LLM searches for the information in that context and responds to that. So this is a wonderful technique to kind of query any external knowledge base like a documents or a web page or web articles. So in this case, we would need an LLM to create embeddings for all the chunks. So in this case, we are going to use Cohere, which is a product which can create embeddings, but we can use any other LLMs, or you can even use OpenAI. OpenAI also has a service for creating embeddings itself. And then we'll have to use a vector store. So in this case, we are going to use a vector store called FASS. And then we also need an LLM to answer the question based on the context and the question. So in this case, we will use OpenAI. And the whole thing will be orchestrated by a LangChain framework. So let's look at that. So we're going to use OpenAI, LangChain, Cohere, and FASS. So creating document chunks, the first will chunk the document, split the document into multiple chunks. LangChain has a text loader and it chunks the document. We'll say character splitter. And we are converting into chunks of 400 characters each chunk. The whole document is probably about 4,000 characters. So it'll create about 10, 11 chunks. And there's overlap. So rather than splitting the whole document into mutually exclusive chunks, what we'll do is we will overlap each chunk at least 50 characters so that we don't lose the context of the chunk. And then we'll split the document into multiple chunks here. And we'll use Cohere embeddings. Cohere is basically a product which can be So here, if you look at Cohere, it provides different NLP-based solutions. It can actually embed documents, do a semantic search. You can summarize documents as well, information, classify, quite a few significant number of services it provides. But in this case, we'll actually use the embeddings. So if you pass a text to that, it'll return you an embeddings. So in this case, we'll use Cohere embeddings. And of course, you have to sign up to Cohere and get an API secret key for that. And then if you ask or send anything, a question or any text, it's going to generate an embedding for you. So what we'll do is now we'll go create a vector store, which is again FAISS. This is FAISS is a Facebook AI similarity search, is a library that allows developers to quickly search for embeddings of multimedia documents. So it also provides to create embeddings for probably images, audio, and text. So in this case, of course, we're going to use it for text. And then we'll pass all the chunks and the embedding service here, Cohere embedding, to create those embeddings and store into the FAISS. So we've done the two steps here. One is split the whole document into chunks of 400 characters each. And then we have converted those chunks into embeddings and stored in the vector store. Now I can configure LLM Open AI. And if you see here, initialize Open AI with a GPT 3.5 Turbo. You can also use the latest model. And we have kept the temperature 0.0 for a very deterministic response, because we are looking for factual information from the report itself. And then we'll configure this retrieval QA chain and pass the LLM and the vector store. So in this case, whenever you ask a question, you'll first look at the vector store and find which chunks are similar to that. That means which chunks might contain information about that particular LLM, that question that you're asking. And then it will add that particular response to the context and send it to the OpenAI for finding the information. So once you configure the OpenAI LLM and the vector store, now if you ask any question, so here is a template that can be used. There's also a standard template there, and this is probably the standard template. Here it says that use the following piece of context, and this is the context that is retrieved when you ask a question. And if you go back to the diagram again, so when you ask a question and the vector store returns the similar chunks in the document which might contain the information about the question, so those are returned, and that becomes the context here. And that context is now embedded here, and says that use the following piece of context to answer the question at the end. If you don't know the answer, just say you don't know. Don't try to make up an answer. So only answer the question based on the information or facts available on the web page of the article. Do not cook up an answer. That's basically an instruction to the LLM here. And that context comes here and the question here. And then if you ask a question now, it responds with the appropriate answer. Now, once we configure the retrieval QA chain with the prompt template here, so you actually configured the retrieval QA chain here. And if you ask a question now, for example, how many EV cars sold in 2022? And it says the response is more than 10 million electric cars were sold worldwide in 2022. And this was actually retrieved from the article. And you can see 10 million electric car vehicles were sold worldwide in 2022. the specific information. What is the expected growth in EV car sales in 2023? And the expected growth of sales is about 35%, which would bring the total number of sales to 14 million units. Though here we haven't specified, the article does not specify about 2023, but it actually makes that saying that expected growth by another this year. So automatically extrapolates that to the current year, maybe based on the article date, which is absolutely correct information. Then you can ask, which are the top markets for EV cars? The top markets are China, Europe, and United States. Okay. So it extracts information and formulates its own response. It does not simply extract a phrase and talks about that, because the overwhelming majority of car sales to date are mainly concentrated in 3 markets. And from that, it would have picked up these 3 pieces of information and have formulated its own response, which is appropriate for the question that you have asked here. And which are the emerging markets for EV cars? So electric car sales more than tripled in India and Indonesia last year, and doubled in Thailand. In emerging and developing economies, the most dynamic area of electric mobility. Of course, it gives some additional information which are not relevant to the question here, which of course we can also add that instruction here saying that only answer based on what questions you may ask, do not add any additional information. That you can also be passed as an instruction. And then if you ask driving demand, what are the policies? Because the article also talk about policies driving the demand for EV cars. List all the factors as bullet points here I asked specifically. So it's the government incentive programs in India is one of the, something that is driving the demand. And EU, so Net Zero Industry Act, which is driving 55 package in the European Union and Inflation Reduction Act in the United States. So of course we have to go and look at what exactly are those, but that information may not be available in the article itself. EV variations, what are variations of electric vehicles that have strong demand in India? So 2 and 3 wheel vehicles have a very strong demand in India. If you're asking a specific initiative and policy, like what specific initiatives taken by China to boost their share of competitiveness in the EV market? The context mentioned that China dominates. It's saying that the context that you provided me has specifically mentioned that China dominates the battery and component trade, and it has increased share in global electric car export to more than 35% last year. Right? And which specific initiatives taken by India? So India has implemented a $3.2 billion incentive program that has attracted an investment of $8.3 billion, which is expected to increase battery manufacturing and EV rollout sustainability in the coming years. Very interestingly, it has pulled out the relevant information. And so it's a very nice idea. So when you're reading, of course, very long article and you're looking for a specific piece of information, we can always, in a conversational manner, we can talk to the article and retrieve and information, relevant information again, and you can build a story board around it. So, so thank you for joining and this particular video. And if you build something story by reading specific web page or article, please post as a link below. And thank you, and see you in the next video.